everyone. Thank you, organizers, for inviting me and presenting my experience about running and creating high-throughput facilities. Especially, I'm thankful because I think I'm only one football player which came and make it to Brazil in June. So I would like to present few my experience from different countries, really, because I'm from Poland, and present you my good experience and bad experience with facilities. Also, financial structures, and what is my best bet, how to run it. So let's start from the beginning. When I was a graduate student in Institute of Biochemistry and Biophysics, Polish Academy of Science, the director of this institute asked me to create the genomic core lab. I was surprised, but I was very motivated student too, and I loved new technologies. So I agreed, and after a few months I got money to buy equipment for this lab. And as you see, we bought 2 sequencing instruments. But the funny thing, I thought about how we organize everything, and we don't have a lot of money. We have a lot of good people, and I decided to put this instrument not to my core lab, to put this instrument to sequencing lab. So we had a simple sequencing facility, and we gave them those instruments. The reason was that I thought that I'm a PhD student. I don't want to really run machines. I'm more interested in how I can prepare samples and how I can analyze samples. So I think that this approach is good also right now when you have a lot of complicated instruments, and PhDs, especially PhD students, needs to learn how to approach problems and to use facilities or use equipment just from not touch them, but how to analyze data, because this is their main job. So I think that structure of the Polish science is very similar like in Brazil. So institutions are supporting the science almost 100%. What we did is a little bit unusual, because we decided that we want to have one large sequencing project as an initial something which start whole facility. I think that was a good idea, but that idea required input from many brains and a lot of PIs. The reason was that Poland is a not small European country, it's medium-sized European country, which was after reconstruction really from communism, and we didn't have a lot of money, so really project needs to show that our facility is operational and we can do the job. So we thought what we can do, and we decided that we need to find our niche which we can be good and we can present data all over the Europe or in the world. So after a lot of thoughts, we decided that, okay, we will be genomic labs, but really what we will be doing will be analyzing plasmids. Whole institute really focused on bacteria and yeast and also plants. And therefore, that was easy material to get, especially that we have collaboration with clinical labs, which have a lot of strains, which were collected after different circumstances in hospitals, and we got very good candidate for sequencing, and we did the job, and we published really this data. The most important thing that we gain visibility, that we really can do it, and that was important for running the lab and to get new customers. So, and of course in Polish institution everything is flowing, and also structure of the institute changed and financing changed. Still personnel was for free for us, equipment we could get for free that was rational to get this but users needed to cover reagents and operational cost and some of the service cost, which was not clear really. So that was the structure of Polish science when I left Poland. And conclusions from that is that institutions are really necessary to support successful facilities, and especially during startup project. And institutional investment in one of relevant project was a good idea, according to me, because it gave us product as a paper and also gave us recognition among these all investigators. And the very important was that facility was a support for salaries, because this is what is really killing a lot of facilities in the United States right now. There's also one, I don't know how that looks in Brazil, but our facility could offer service for another institutions for the same price. So that was not that we are, for example, from IBB, and there's a special price for IBB customers and another price list for outside users, which is right now in United States is like that, for different reasons. Okay, we are swimming to United States. So we are located right now in North Carolina. And when I came to North Carolina, I went for postdoc, not to create facility. However, it appeared that I was so into genomics that that was one option which I couldn't miss, that I would like to use microarrays. At this time, microarrays was hot topics for the research. But right now it's, of course, sequencing replacing it. Then I would like to tell you a few things about my bad experience with facilities. So when I moved to UNC, facility was located in Lineberger Cancer Center, and so most of the users were from Lineberger Cancer Center, which is the richest institution, and they have set of PCR products which they could print on their robot for human analysis, but I worked on yeast, and many people worked on Cenorhabditis elegans, so worm. So that facility was really not available for us, especially when we asked, okay, we can do something together and work to make this happen, to prepare PCR product, 12,000 PCR reaction and print it on the array. So facility was not interested in this. So we built underground facility really, because we got $50,000 from one startup money for one investigator, and I and Jason Liep, we built ourselves this system. So this is very simple system which really you can do at home if you have $50,000. But you can print microarrays, and of course that required like 4-6 months of work to not only build this machine, which is like 2 weeks of work, but to purify TAC polymerase, which will be used for PCR order primers from Illumina, because Illumina at the beginning was primer company, and create this. So I think the lesson which I learned from this experience is really that facility needs to be flexible and needs to be open on new ideas, because this is their job really. So that was conclusions. But I decided to implement these ideas in a new next generation sequencing facility at UNC, which I was asked to run and open. So that was our mission statement, because in the United States everything needs to have a mission. So this is our mission. Of course, everybody wants to be the best, so we also want to be the best high-throughput genomic center at public universities. And this is public universities. It's completely different financing for public universities and private universities. We would like to have the cutting-edge equipment, and institution is obligated to keep this running, to keep us on the edge. And also, very important, we need to help researchers design and interpret genomic experiments. So not only that, for example, somebody is coming to my facility with samples, I always need to meet with him and talk about project, and we decide that this way, this type of application or kit will be the best for them. And after that, I'm directing him to special bioinformatic groups which can analyze data or help him analyze data. So this is our standard service. We are not charging for this type of things. This is, I think, our basic. This is something which we are working still. This is work during progress. The reason is that, for example, we thought that we will be open for all other universities, but this is not very simple in the United States system, just because you need to charge 52% more clients outside of the university. So there are special agreements between universities to avoid this 52% charge, and we are during negotiation with other universities in North Carolina to bring this system as a whole. So this is one of the things which, for example, in the United States, companies have advantage because they don't have to pay this 52% more. They're just independent companies. And we are losing edge on this field. How look like financing of our facility in 2008 when it was created. So as you see, those are categories. Yeah? So this is simplistic graph. What includes reagents, operation. So operation means plastic or consumables. Personnel, service contract and amortization, and equipment. So initially, university was very happy that we will run whole operation there. And that was important because of two things. First, that this is something new, and the university can show that they have a new facility with new generation equipment. But the real reason is that without good high throughput sequencing facility, access for the federal grants will be very limited. Why? In American system, when you're applying for grant to NIH, to NSF, to another organization, you need to show how you perform your grant. And if you don't have a letter from facility or somebody who will do sequencing, your grant is much weaker. So you need to show that you are able to perform this job. And letter from facility which support your project and saying that, okay, we will do this for you and we have capacity to do this. It's very useful. Sometimes people are applying for huge projects, multi-million-dollar projects, which required thousands of samples for analysis. And when we have like 3 machines, for example, this is not enough. We don't want to invest in new machines because we don't know that this grant will be funded. So what we can do? The easiest way how institutions dealing with this problem is that I'm sending letter from me. We will do this project, but we will need 1 or 2 more machines. Institution is sending another letter attached to my letter that is we will buy 1 or 2 machines if project will be funded. And this way it's just depends on the number of projects and how large a project. We're gaining more machines and more. So projects usually on 5 years, so we have coverage for these instruments for 5 years. So, but when we created this facility in 2008, there was not a lot of money on the market because that was crisis in the United States. But we are lucky because state of North Carolina is funding every year about $25–50 million to improve cancer care and for research on cancer care. So we use this money. However, the strategy in this case was that we will found like 15 small grants, $20,000 to start sequencing facility working. That was not good idea, I think. The reason was that people sent a lot of application for these grants, and when they got it, appeared that they are not ready for sequencing. They need to first prepare samples and prepare experiments really, and after 1 year we start getting samples. So we have this 1 year period that we will sequence like 300 samples really from different sources. And I thought that really this facility will fail soon if something not improve. But we got big grants and then we will start really well. However, in the first 3 years, institution told us, okay, we will cover the most important cost, personnel, as service contract without amortization, because we decided we'll not do amortization because that will kill the price for the users. So that was very important, but we had 3 years, and in 3 years we had to make a revenue which will cover all this cost. And right now this cost is around $700,000, which is not a small number for us. So this is like last year. So we are covering, users are really covering all reagents, almost all personnel, service contract without amortization, and sort of equipment, smaller equipment. So as you see, we shifted a lot of things on the end users. I know that this sounds awful from a perspective of people which are not paying for this type of service, and in Poland also that could be very difficult to get through, but this is reality for many for all institutions in the United States really. But that also has some advantages. I have to tell you that when I was in Poland, where many services were free, people didn't thought about cost at all. So people sent samples which really never end up in any publication, and they were just they wanted to do something and to show that they are doing something. And when you need to pay not a lot of money, then you start thinking, okay, I need to really think what I will send for sequencing because I need to pay for it. So I think this is a sort of advantage for this type of charge structure. But on the other hand, institutions which funding science needs to do also something, because they need to be sure that people will start using facility in correct way. Then if you're applying for grants and you have sequencing or any other type of analysis, you'd say, okay, this and this amount of money I will send to facility and I will use for facility for this project. And then institutions which are funding the grant also knows that this money is really going where they should go. So this is like, circulation of the money. And all our, for example, institutional grants, small grants, not only require this that you need to put them into the grant, but required letters from me that I talked with the person who is applying for grant. And after this conversation, I am sending email that, okay, this person was here and we talk about his project. So this is real thing. But this is internal. NSF and NIH, it's enough to have a letter Okay, so when we started in 2008, we had two instruments. First, not this was next generation, but first generation of next generation. Those are Illumina GA2 systems. And we grew up that we have right now 10 HiSeqs. And when we created facility, I never thought that I will have 10 HiSeqs. I thought that maximum will grow for 3-4 instruments, which are extremely expensive. And it appeared that, okay, we are located in this building, and we got 2 additional GA2 machines, and we used all power on the floor for machines and servers. So we were kicked out from this building. Institute find us another place, in another building, which we moved, and the Lineberg Cancer Center bought us 4 more machines. So we had 8 machines, GA2 machines, which operated in one big room, but appeared that we have enough power, but we are using all air-conditioned system, and we are not really, there's no cold, it's not 23 Celsius degrees in a room. But the worst, when we start transferring data, we are using all internet throughput. So all internet in whole building is going down because we are just sending data. So after 1 year, we were kicked out from this building too. Appeared that the best solution for us will be to just build new building. And there were different plans. I decided that I will support option in which this facility, which handling all these heavy instruments, will be in another building, and other instruments will be at the campus, let's say. So we split really facility because of the electrical power, efficient air condition, and fast internet. So UNC renting right now building outside of the campus, which have all these 3 things with special room, with special power and protection, and efficient air condition system, which was not efficient at the beginning appeared. We had to install additional air conditioners. But right now we're keeping all these machines in a separate building. So, but to have this machine, we had, as I said, 8 GA2 machines. So the first rule, my rule, is that I cannot be attached to the equipment. So I need to upgrade this equipment and make it better. So don't be attached to your equipment. This is the rule. So right now what we have 6 HiSeqs 2500, 4 HiSeqs 2000, 1 PacBio instrument, 1 PGM ion torrent, 2 ion protons, and 3 MiSeqs. And on the campus, additional microbiome facility has 454 and 2 MiSeqs in a user's hands. But those are not really users. Those are lab, which is prepared to move towards clinics. Okay. So Lineberg Cancer Center has pathology department with pathology people, and they are creating next generation sequencing protocols for hospital. And these people are keeping these machines because everybody can operate these machines. I'm not keeping really, they're not sequencing a lot, but they have it. And I didn't want these machines in my facility. The reason was that it was too simple, and HiSeq 2500 is much, much better. But this is like my PacBio looks like, for example. Those are HiSeqs in our special room outside location. This is in the building which I'm right now with my library prep systems. But what you can notice, this is huge machine like car in one empty room. This room supposed to be for 10 HiSeq machines, but appear that it's consuming so much energy and air condition that we can put only this one machine. So you need to also be careful with what type of equipment you have, because you don't know that people want to use it. And this is example of equipment that everybody were excited, but there was no users. First user which came to us, we sequenced and we got crap, because really from this first 2 years from this machine you could get crap, nothing useful, and they were complaining. After 2 years, this machine, technology changed, and we could produce real good data. So what I would like to present you here is that our development of facility was correlated very strongly with acquiring new grants, not by us, by our users. And I told you that we are started replacing machines and support on different level from institution, but as you see here, TCGA was one of the first large grants, and for this project, which is 5 years, we had to prepare minimum 8,000 RNA-seq reactions. So this is another low-pass human genome sequencing, 3,500, 1,000, 1,000, and Nexus, those are starting this year. So as you see that this is, if you imagine, those are really large grants. And when you, in United States, when you're getting from an NIH grant, you are, for example, you are applying for $200,000. You are getting indirect, institutions getting indirect cost 50%, which is $100,000, which users don't see it. This is just like under table. Institutions see it, and this is the reason why institutions are very interested to acquire all these big grants, because this is not only a lot of money for research, but also a lot of money for institution. So it's a very strong pressure for scientists to get new grants more and more and more, because university is having money from this. So right now, our money from grants is around $800 million per year for whole UNC. But what type of projects? This is just something interesting, maybe you, and TCG, this is the Cancer Genome Atlas project, what brought us this project really? This project brought us expertise, which is really the most important in market. We are one of the best right now in RNA-seq. We can do massive projects for us. And so right now we got $25 million grants for clinical sequencing of our RNA-seq. And this is few institutions in the country could apply really. So that what brought us to create this facility and to keep this expertise in our place. Those are projects which are producing 3,500 low-pass human sequencing, and we don't know how data will look like still. NC genes, this is something what was very in interest of the United States, is just a Mendelian disease or not diagnosed cases, which we are sequencing, and we can sequence around 600 patients, maybe 1,000. And NC Nexus is the project that all newborn, there's the idea that in future all newborn will be sequenced. Just after the baby is born, we'll put them on sequencer, we'll wait 24 hours and we'll know that this baby required some care or not. So this is idea. But as you see here, 40% of our sequencing capacities are medium and small projects. Small project, I mean that somebody has 2 samples and want to sequence, and we still accepting this. So this is the reason why we keeping our facility as a facility, not the institute or center, because all these higher level organized facilities, for them it's very difficult to accept 2 samples. They want projects because everything is about money. And as you see here, and this is our ranking, and right now we are around 15 in the world as a sequencing capacity center. But we don't want to be here. We can be over there. It's not important, really. And why it's not important? So from my perspective, large grants are very important. We are producing huge amount of data. But, for example, project by itself and papers from these projects, it's not a lot of papers, actually. Those are big papers, like in Nature, but when we have cases that somebody has sequenced 10 samples and had a paper in Nature. So everything depends on ideas, really. So my favorite always projects are on a basic organism yeast and plants or something like that, which gives very easy and very good publications because of the good ideas. But when you see at UNC, this is in 2011, when 2 years after we start, we had turned around about 15% of all facilities at UNC, and right now we have 30%. So this is a lot of money to turn around, and it's becoming a lot of samples. And also, there is one more thing. We are bigger and bigger, but this is not only sequencers. It appears that there is a next step after big facilities. This is bioinformatics. And really, data analysis are on bioinformatics side. So when we're producing 3.5 billion databases per week, we need to handle this 3.5 billion. And this is the reason why university, instead of supporting right now facility, supporting much more infrastructure for data analysis. And that's becoming really critical. So UNC right now, it's obligated to put around $800,000 per year for big sequencing centers. No sequencing, big analysis centers. And I will show you this here. This is our graph, how our flow of data looks like. So in theory, when you're buying sequencing system, it's coming with server. And this server can analyze the data on fly. There's one disadvantage of doing this. When you're doing this, the 24 hours after sequencing, server is still cranking, and you cannot put new samples because something can happen. So what we decided to do, that we'll have storage server close to our machines, which transfer data directly, not analyzed fully, to the data server. And after that data server, sending data to big data analysis cluster, which this is investment like $2 or $3 million from, or maybe even $10 million. A big analysis cluster, which is keeping the data, about 2.3 petabases for 2013, and analyzing this data. After that, data can be sent to smaller servers, which will be also cranking specific type of analysis. Data are stored for 6-12 months on the storage servers, and after this time, we are putting on the tapes in special facility, but this is not university facility, this is company, for 3 years, and we are throwing away. So right now it's becoming like that it's really, sometimes it's easier to resequence something than try to reanalyze or deal with all the data. And of course, if you are creating big infrastructure, first you think about people and who can analyze this. So there's a lot of really departments which are dealing with big data. And right now they are dealing really 80% with sequencing data. This is Center for Bioinformatics, which is closest to us. They are doing real job for first analysis. Linear Cancer Center, which is dealing almost with TCGA and also some UNC-seq data. Research Computing, which is leader with this big machine for analysis, and RENCI. So I need to say a few words about RENCI. RENCI is the institute, High Computing Power Institute, which was created between three institutions, UNC, Duke, and NC State. And this is very unique institute because these guys are really high professionals. They are dealing only with big data. So they have their own super server, but they are using also our cluster because it is newest and fastest. But if you are interested, for example, to have a knowledge and know-how about high computer and data analysis, I can give you some contacts to RENCI because I have to say that those are great people, very friendly and very knowledgeable about this. Okay, so error rate. Each facility has error rate. Somebody swapped the sample. If you have not a lot of samples, hundreds, error rate is low. Somebody in facility can just put sample in the wrong rack and sample is processed. But when we are start dealing with hundreds, thousands of samples, so that's becoming a real issue. How to prevent that our error rate will go up? So LIMS, this is Laboratory Information Management System, LIMS, is key for one part of this issue. And second is automation. So at the beginning, we were forced to use BSP LIMS system. So BSP really, this is a LIMS system from bioprocessing facility, which we try to adjust for our use for high throughput sequencing. And that this is disaster, let's say. So I do not recommend you to invest money in correcting something. I really strongly recommend you to buy something from professional company which they know what to do and how to do it. So we are right now implementing Clarity LIMS from Genealogic, and I know that this product is very nice and not extremely expensive. We have users which have people with bioinformatics skills, so they're creating their own LIMS system for their projects, which we are follow. But as you see here, there are three steps really for processing all the samples. This is how you acquire your samples and your storage, your tissue or plants or yeast or whatever. And you are preparing libraries and you are sequencing in facility. So really what we did is we are treating these two entities separately because I'm responsible for this part. And these two things units are located in completely different places. Therefore, as you see, we are not extracting DNA or RNA because this is too much for us. Customers need to provide us DNA or RNA, and we can process this in different ways. Different, that means we can do everything what is available right now on the market or completely 100% custom protocols. But that will require some involvement from LIMS system and modification of LIMS systems. So in the real world, what we are doing right now is that all big and medium-sized projects which have protocols established, and smaller, but with established protocols are going through LIMS system, and projects which require customization from the beginning are going separate track, completely separate track because that will be very difficult to follow them through this process. And automation, and I think that for big labs which are growing, automation is completely critical. It's not because it's fancy and required additional new toys. It's just the error rate, it's really improving using robots. And for sequencing, we have few bottlenecks which we right now dealing using automation. It's fragmentation of DNA, for example, and preparation of libraries on high throughput scale or in medium scale. Custom protocols are still done manually. And after that follows quality control. And quality control takes a lot of time, especially with some new technologies which Illumina and Agilent right now introducing with topoisomerase, which avoiding fragmentation. However, quality control is key issue. Okay, those are instruments which we are using for the automation, and this is for high throughput fragmentation, and this is for 96 samples. So a few protocols which this machine do, and this is it. My beloved instruments are Tican machines because I can do everything with them. So we are collaborating with Tican, and we are creating right now a new machine which will be oriented for next generation sequencing. We already wrote many protocols, and Tican will be distributed this month, everything. And the most important, I don't want to take more time, but the most important really, I think, are people. Because of the expertise. People are sending samples to facility not only to just do project, but to do this well. And if we will provide not only that somebody will do it, but will talk with the users and explain them that this way maybe it's not the best way. I will talk with you and will show you how to do it the best way. People are very important. So we are training people all the time. We are sending them on the conferences, on user meetings, because they need to know what is the new on the market. Also, always we have, in our new structure, we have this idea that one technician is responsible for one project. And there is a connection always from lab, which is sending us samples. I'm asking, okay, give me the contact person, and they will talk together about this project, and they will collaborate. So everything is based on collaboration, really. So because I experienced that when people are sending samples, we are not contacting people, and or they don't contact us, and the data come, they always complain for something. So we have clear situation, what is possible, what is not possible. And right now, because we grew, we decided to change completely our structure. And this is a new structure. We will have combined genomics. Many faculties will say in this like a CEO board. And here are different facilities which will be integrated, not integrated because they want, but because they are not bringing profit. Not profit, they cannot sustain themselves. So we decided that we will integrate all other facilities like genotyping, all the, yes, especially genotyping, and also will be here microarray core, which will bring expertise together, and then we can much better operate. And so I'm moving from the running this part because managers already know what to do, and I decided that I will go over there and will be for research and development. So conclusions. So I think that initial startup should be well designed, that when you have equipment, you can start project. Just whatever project it is needs to have a sense, but people will learn how to operate machines. Without that, they will learn on the user samples, and not always this is a good idea. Yes, development facility in our case, I don't know how in Brazil, will be correlated with large project. Infrastructure needs to be designed this way that in 2 years, 3 years, when you put in more machines, you will still can sustain your facility. Flexibility. So this is a very important point, I think, that interaction with the users, and to provide them not only just we will send you data in 2 or 3 weeks or 2 months or 4 months. We just work with you how to do the best job, and we will inform you if we have some problems. And LIMS and automation with growing facilities, I think, very important. And I'm always saying that people are key for success. Thank you. and those are people which are in my lab. So we are hiring people not only for the running machines, but for example, this is my postdoc, which is running robotics design, and she is producing scripts for robots, customized scripts, and doing also R&D and working on yeast when she has the time. Thank you.
Good afternoon. My name is Emanuel Carrillo from Institute of Chemistry of São Carlos, University of São Paulo, and it's a great pleasure for me to represent one of the 12 mass spec multi-user equipments that Professor Brito mentioned this morning. So it's more than an honor, it's a big responsibility to show a little bit of how we implement this project in São Carlos. So I want to just show you the instrument. It's a high-resolution LTQ linear trap, quadruple orbit trap Velos from Thermo Finnegan, and it's an equipment that's capable of giving you 120,000 resolution, mass accuracy of roughly from 1 to 0.1 ppm in mass accuracy, and just for you to have an idea of resolution power, just a regular envelope of carbon isotopes. And this is one single peptide with 24 state charge. After the convolution, you can see the resolution of almost 1 ppm in terms of such a big protein or medium-sized protein. But I'm not going to go into more detail than just to tell you what's the instrument that we have there, but also a little bit of on the background, the story, a little bit of the behind the scenes of this instrument. So we get this the multi-users call in 2009, and we submitted, let's go first here, as a team from Institute of Chemistry of São Carlos with many associate researchers, many collaborators. We've put together many research proposals from proteomics, metabolomics, quantitative chemical analysis to environment. So we had to decide for one single multi-user equipment that could do all these tasks. So at the time, and maybe up to today, this single equipment is one that could comply to all that, from high resolution, mass spec, high mass accuracy, relative good quantitative data information, and then all this structural elucidation. So we can go through a new molecules and refining a new isolated compound from natural products or synthetic chemistry. One of the requirements from the call was that we have all this information in a good website. And that was actually an interesting story. Kind of 1 month ago, I got a call or an email from the auditing sector complaining that the link that I provided didn't have all the information that was supposed to have there. So the funny part is that the entry page of the equipment was how to book time to use. It was just send an email to this address, and that was the only information. And the auditing said, oh, there's no, what's the advisory board, or what's the protocol, what's everything, all the things that okay, so if you want that information, you go to this about address, or you see all many other events you can have. So, of course, we are way behind. We cannot compare ourselves to the facilities that we've seen in the morning. But I think we are doing a decent job in terms of having instrument running. So another fact of this instrument going to São Carlos is that FAPESP pre-approved this instrument to us, but also pre-approved on one high-resolution equipment to Federal University of São Carlos. That was a proposal from Edson Rodrigues Filho. And they called both of us here for a meeting, and then they told us, both of you should find an arrangement so that one instrument goes to São Carlos. After a short conversation with Edson, we decided that the instrument would go to USP, not a federal university, because we, that time, had a better infrastructure to offer. And then we just amended, we merged both proposals, so we add some more instruments in sample prep that Edson was requiring, and from that we got approval, and we're going to see all the equipment that we have in a minute. So we have this steering committee, or the managers of the equipment. Daniel Rodrigues Cardoso from my institution is is a great help. He's set up all this online agenda. He's actually the one that he's most of the time in the lab running the equipment with his student. So between the three of us, we don't have a trained technician working in the equipment, but the equipment is located in a central facility, the Central Analytical Chemistry Facility. We have 4 or 5 PhDs technicians running all these instruments, but for now, since this equipment was a project under my responsibility, the equipment was not totally given away to facility, but is under our control. And 2 or 3 students from myself, from Edinho, or from Daniel, we run all the samples that we receive so far. So we put together the both proposals. We merged the people interested in using this equipment from Federal University and also from our institution. Maybe João didn't know that before, that he's in our users committee, but yeah, we hope that users committee will meet eventually and give an appraisal how the instrument running. At least Edinho always tells that the equipment is doing a terrific job. So in this presentation, I also thought that it would be an opportunity to give a prestação de contas to the society to show what was the numbers that we got. Initially, we had approval about $1 million, and then the technical reserve for importation, technical reserve for the project itself, plus the same amount for the institutional technical reserve. But the fact that this call had this technical reserve was very important, and I think that was a great improvement from the previous multi-users calls that didn't have that technical reserve. So I think that was very good. And the flexibility to use it, we can see that I actually used half of what I had before because I added much more equipments to the portfolio of your facility. So I imported 2 other equipments using the technical reserve. So we didn't need to get for $1.2 million. I just used $1.2 million for equipments, but I actually, the technical reserve was used in half of it. And here we see that the original proposal was just the main equipment and this, some of the sample prep that the people from Federal University requested. With the technical reserve, I imported 1 preparative chromatography and 1 additional interface for sample preparation and infusion in the mass spec. So what we have there, we can offer all these service directly, an electrospray ionization from a nanosource interface, just from microliters of samples you can infuse into many hours or many minutes of experiments and do structural elucidation, MS to the MS to the MS to the N with the LTQ, the ion trap in front of the high resolution mass spec. It is actually a hybrid of 2 instruments. One can give you MS to the N capability, and the other give you the high resolution down to 1 ppm mass accuracy. Nano electrospray interface is essential for capillary liquid chromatography or other nanosource kind of interface. And we have also, in additional, another ionization source that's atmospheric pressure chemical ionization for less polar analytes like some natural products. Electrospray is great for polar and charged peptides or compounds, but APCI is needed for less polar and neutral compounds. And we also, one of the instruments that we bought using the technical reserve was this DESI, disruption electrospray ionization, that we're going to see what it does in a minute. On the original proposal, we get 2 separations units, 2 chromatography equipments, one for nano LC or capillary LC for proteomics, and with capable of doing multi-dimensional ionization technique in the mud pit, or known as LC-LC before the MS-MS. And one nowadays the standard-of-the-art of chromatography, ultra-high performance liquid chromatography, all from thermal, and a few accessories or sample prep, like as I mentioned, the Acta Prime from GE that is to use as a purification protocol for proteins, and the 2 equipments that is actually located in Federal University for sample preparation of natural products, lyophilizer, and concentration. So we were very excited at first because back in 2009 we would have 1,000 square meter new building, and that building is still like that today. So back then in 2009 we actually had the foundation of the building already done, and because of not only a problem of the university, but the company that was hired didn't want to do the job, and then the following one said that the first one didn't do the right job, and they just want to go to the market and make the MRV, the Casa para Todos, lá como é que chama o programa? So all this, they go to the market and build houses for instead of building a research building. And but I like to see a container. So maybe I hope FAPESP can allow to put containers in the proposal, because that is a nice place to have many containers. If Professor Brito allow me, in next grant I will have many containers as labs. But thanks to the institutional technical reserve, we adapt one space. We build a new lab. This would be what we call CAC 2. That is Central de Análises Químicas Instrumentais 2, where we have here, see this door. Actually, we have 2 multi-users equipment. The next one is the RXD, the X-ray diffraction. And this is the room that we have the mass spec. You see it inside the room. And there we have all the major equipments all together. The linear ion trap, the orbit trap, Velos in the back, the nano LC instruments, and the UPLC with a remote control and computer for data processing. We have also this, all these benches made by the technical reserve. There's a space to operate the samples and put everything in place. The few accessories that is listed, if you go to all the multi-users equipment under my name, you'll find a lyophilizer that is at actually Federal University, and the sample SpeedVac is also in the Edinho's lab. So all of that was imported through the major proform invoice. The separation unit, we see the LC, all the, as mentioned before, the Acta purified that it was imported 100% using the technical reserve, and just going more to details in the ionization source, you can see that the nano LC, the nano electrospray has to be coupled to the capillary LC chromatograph, and we are now about to install this desorption electrospray, which can infuse sample directly from a surface, like a TLC plate, as a leaf, as a paper sheet, or as any solid material that you infuse directly electrospray over the surface, and that ionization process goes through inside the mass spec, and that was also imported using the technical reserve. Using this as a facility, we're using other funds like CAPES, Pro Equipamentos. We bought one robot station to infuse automatic samples. So for people that just want structural elucidation, high resolution mass spec of single compounds that do not require separations, we just load the equipment, and with a 96 well plate, and with the robot we will infuse in using nano to microliters of sample effortlessly. So just to give you an idea of where we spend the money of the technical reserve, we're gonna see, we cannot read there, but if you separate in things, you see that 50% of the money was spent on consumables. Some of them using infrastructure like the air conditioning, the benches, and the preparation of the room, reagents, the consumables, so like capillary columns, HPLC columns, and so forth. So, and this was just the half of the money, because half of the money I was using importing the other equipments. Because we had such good amount of money, I did not charge anyone for the samples. So you can see that the instrument was up and running in February 2012. From that time to today, there was no downtime. There was only one circuit board that was burned in between them. But since after, we can see that this is a regular schedule that we can see online. Since June 2013 that we implemented this online scheduling, we can see that there was not a single month with downtime, or there was no users using it completely throughout all this time. So as an overview, we can see that in just this last 1 year, 12 months since we started this online agenda, we use 265 days out of 365. So if you count Saturday and Sunday, we give a break to the students, so they don't need to work, but the equipment was up and running all this time. You can see, maybe you can see all the names and most of the users. Of course, our institution is the one that has myself and Daniel most of the time ahead of it, but we have many other users. The Rede is Federal University of São Carlos, but we also have Ribeirão Preto. By the way, we many mass spectrometers over there, Embrapa in São Carlos. Even people from abroad have come and used our equipment. So come to the end. I'm late to give the final report, so I need to do this next week. But after that, the grant is over, and I will start to charge. As I see, this is a preliminary idea, so we're going to start to learn a little bit as we go along what we should charge. But I think those numbers should be reasonable to at least give some cushion to make it work at first, because we can also use money from our graduate program, ProX money, and so forth. And I think I would like to conclude that I'm very happy that I can brag myself that I'm 100% granted EMU. In the first call in 2004, we joined with Marina Tavares in the Institute of Chemistry in São Paulo and Adela Maia from Unicamp in the first capillary electrophoresis coupled to mass spec equipment in Brazil. And because of the same call, I could be only in one proposal. I help all colleagues also in São Carlos to have another equipment in São Carlos. But this one was trouble for many, many years, but only now it's up and running. And 2009 was the call that I led. So I'm really looking forward to see a 2014, 2015 multi-users grant, and I have a wish list here that goes very far away. So I would like to conclude. Thank you, FAPESP, for all the support throughout this year, and you for your attention. Thank you very much.
Saber como que você faz, se você envia o protocolo para as pessoas prepararem a amostra, como que você faz em relação a isso, aos contaminantes que podem vir juntos e sujar o equipamento que você tem que limpar por um mês, como que isso é feito? This is a
very important point. We try to make the students to run the equipment. We have one technician that oversees the whole operation, but the two students of mine, 2 students of Edinho, 2 students from Daniel, they are trained to all different interfaces, and they are the one that will run the sample for you if you are just a user that bring a sample and you don't have the student interest in learning the technique. So that was a compromise that I did with my students and with Daniel's student said, you want this toy for your thesis, you can have it as much you want, but you have to run the sample from people that will come from abroad, from outside the wall. If we, right now, we are now negotiating with my institute to have a single technician running over for all the samples, because that is important to have one single person taking care of the equipment, but the users, the student, should be the one that should learn the technique and design the experiment as we develop the data.
Any more question? I have one actually. You show us your perspective of pricing, charging for the service. Could you elaborate about the cost? How much this charging will cover the cost of the operation? Or?
That was not any very elaborate equation. It was just a perception of what's reasonable to have people inside, the average of the cost that we see other equipments, a little bit of the consumption, no depreciation or anything. I was just making a quick calculation on depreciation, and cost should be $75 per hour. So if I'm just charging $10 per sample, that's subsidized for the people that is inside the institution. But if from industry, it would be 10 times more. So that can be an average out. Of course, we cannot deny that we have the support from CAPES, from ProX. So we put a lot of like the nitrogen, helium, all those gases we simply buy from the graduate research, graduate school research, and then we try to implement this balance. But we're just gonna start now. We'll see on the monthly basis to see if we spend a lot more than there is income, and then we will raise up to at least be stable.
Thank you very much. Good afternoon. Thank you, Professor Brum, for inviting me to talk about our LCE, that's Structural Characterization Laboratory. This is our building, our laboratory. We have 1,000 square meters, and we moved to this laboratory in 2008. So we had some experience in microscopy before being considered as a general facilities, in fact. General overview, this is, we are at the Federal University of São Carlos, in the city of São Carlos. We are based in the materials engineering department. We started there, in fact, and we continue there. And I'm talking about São Carlos and the location because of the next slide, but São Carlos has a lot of academic people. Embrapa, 2 campuses, UFSCAR, Federal University and State University, 700 companies, and but we are not, we don't have an easy access. Our nearest airport is Campinas, and I'm just talking this because of this slide here. These are our users in the period 2012-2014, and we have people from, in these 2 years and a half, people from the whole Brazil. I think that's very important. And São Carlos is not really easy to reach, I can tell you. If you are going for 1 day there, it's really a big problem. I'll be back to this a bit later on. We started in '76, our first electron microscope. I was an undergraduate student at that time. That was FINEP. Then we went to '81, our first TM. Again, it was FINEP. At that time, I was already a master's student. And in '89, there was a large program for electron microscopy where we got our second SEM. It's still operational. Nobody wants to use. You can see the knobs here, but it's fully working. And in '95, PDCT FINEP program, we got our second TM, ZEISS. Unfortunately, this machine is no longer working. And within the same program, and for the first time with FAPESP money, we bought our third TM, And this is the CM-120. And this machine is fully operational. We will see the numbers on it. A lot of people still use it regularly. And since it was installed, in fact, in 98. And finishing with the TM facilities in 2006 with FINEP money, multi-users again. We bought this analytical 200 kV FAG microscope, which is our best equipment for TM up to now. In the SEM facilities, now we are, I'm just talking what we are running presently. 96 FAPESP multi-users, we bought the first SEM FAG, and this microscope is still running full-time, and is the most used microscope in our lab, in fact. 1 year later, we bought a much smaller machine, a tungsten SEM for general users. This is still running again. That was with combined money for many, many sources. 2009 or 2010, again, FAPESP multi-users, we bought a Magellan that is a FAG, is a high-level microscope, SEM microscope, and we bought, with the FAPESP money, there was this EBSD, and we used, again, many different types of money to buy a new machine to put the EBSD that's not shown here, it's just behind this. So we have this inspect machine. We also have probe microscopy, again, FAPESP multi-users, 96, the first AFM, and 2010 again, the second AFM with a complete probe microscope in this case. We also have X-ray facilities. We have X-ray diffraction and fluorescence. The three equipments came from CAPES money, optical microscope, FAPESP, thematic money, and a confocal with CAPES money, and odd sample preparations for metal, ceramics, and polymers. We don't have for biological, unfortunately, but we have chemical and all types of preparation except dual beam. I'll mention a bit later, but that's cryo ultramicrotomy for polymers. And all the sample preparation came from FINEPIS, NPQ, CAPES, and FAPESP. This is a lot of equipment that we have there. We also have a mission, but it's not because we are asked to have a mission, but it's just to focus what we need to do because we have a lot of demand. And what we think that we should do is to provide high-level facilities for structural characterization and support, scientific support, to the academic and industrial community which wants to use electron microscopy, optical microscopy, probe microscopy, and X-ray diffraction. That's what we do. We put our lab, in fact, our focus is on analytical microscopy mainly, not in high resolution. We have no conditions to compete. We don't want, in fact, we have more microscopes in UFSCAR. Professor Edson Leite has one high resolution, Synchrotron has high resolution, and so on. And we have a few commitments. And again, we have these commitments just to focus our actions. We try to have a good high-level performance of our facilities. And we are very worried about maintenance of the equipment. And I'm very proud to have the CM-120 and the FAG, the first FAG, which are still completely operational. From 2005 until now, we never had one single year without covering fully maintenance of all the lab. Because of the way that we run, we need to do a lot of teaching and training. So we have different levels of education and microscopy, from high-level graduate course to short course and equivalent training. We want to give complete accessibility to the user, so we have optimized user facilities. And in this case, we have a double or a hybrid system. We provide operation by the technical staff, but also supervision for all users who want to receive training to operate independently the equipment. And our equipment are typically available in no more than 50 days, but if someone needs urgently, we can always, in 2 or 3 days, we can arrange that because we run until 8 o'clock in the evening, we can always manage to solve urgent problems. Another commitment is scientific excellence. That's a very important point because we are quite, it's not criticized, but we are asked all the time, how can we be sure that we have good results since we open our laboratory to all users. Even undergraduate students can operate our most sophisticated equipment. So it's really open lab. But my response is always that most of our users are from the top graduate programs in material science, engineering, chemistry, physics, medical, and dental school. We can see that there are graduate students, and well, I'm very proud to say our graduate program is has the 7 since the beginning of the evaluations. It's the 5th time in a row, and they are our largest users. And the final commitment that maybe after what Professor Brito said today, maybe I change that. We have a highly reduced fees for public institutions. So we charge, all the users pay for the use, everybody pays for the use, but public institutions have a largely reduced fee. I'll show that. Now, our concept is to be multi-user and open facilities. And I think this open is very important. So this is our home page. You can see here, FAPESP EMU is here. If you want specific rules from this last bit. But we can do the, we click here to see if you want to do, to reserve the equipment. And, but because of our systems, as I mentioned, one very important point is teaching and training. So we can always go to this part here, to this teaching here, and we have 2 sessions. One of them is teaching and training. And so we have, every month we have teaching is for 3 equipments, not for all of them, because we have a series of a sequence of learning, but if you want to learn how to operate the SEM, you know when you have to be there to book. Of course, it's always paid, but it's only paid the normal rate that you would pay for using the equipment. And we have plenty of equipment to allow people to get trained without paying. So after the initial training, they can be supervised in smaller equipment to get as good as they want, in fact. So we have this training, and we have also in this teaching area, we have this, what we call a School of Microscopy, and we offer this since 2002, if I'm not wrong. And so we have a series of courses, introduction, usually they can be 3 to 1 week course in different subjects in TM and SEM. So here, this is just for 2014. We already did these courses, and typically we have 60 participants per year. And this course includes, of course, operation of the machines. And we have, in the graduate course, we have 2 courses in electron microscopy, 1 and 2, for people who really want to learn the fundamentals. Now, I'll come back to the concept of multi-user and open facilities, and if you want to make a reservation of an equipment, you just click, and all the users, that they have to be registered, and this means that a student will be registered by his supervisor unless he has a grant. He has a technical reserve grant from his, then he can register by himself or herself. So we just enter here after you are registered, and here it is like we can make a reservation. We can see, in this case, I put the wrong one. I can offer myself to operate an equipment if I want, and I can see many reports of people who are using and so on. But what we see, we can choose one equipment, for instance, from our list here. I'm choosing MEV Magellan, for instance. I enter. This I did yesterday, as you can imagine. And you can see this is the booking for, sorry, I switched the thing. I put Magellan here, but in fact I put the page of the TechNI. sorry, I did in different points. But you can see that's the way that we see the weeks ahead. And for instance, if I come to this point here and reserve, open this window here, and here I can choose. If I am allowed to operate, if I already had been given authorization to operate, I can just book it. Otherwise, I can choose a technician to operate for me. So in this particular case here, I should choose if I want a technician or if I don't want a technician, but if I'm not allowed to book an equipment, I can only see the slots where there is available technicians for it. These are the prices that we charge. We charge, for instance, the most used equipment that we have, the SEM, is the Philips, we call the XL-FEG, 60 reais per hour for institutions, 220 per hour for the industry people or the companies. And we charge sample preparation and so on. Sample preparation we charge only if we do, but we give all the conditions for the students to do, and then we don't charge. But if they ask us to do, then these are the price. Once we book a slot, and after you use it, you have immediately what we call a service order, where you see how much was the cost, and then how much you are going to be charged. And so for you to be able to use, you have to give a project which is going to pay for your use. So that's why everybody has to be registered with a project and has to indicate which project is going to be used. If a student book, they can book by themselves. The supervisor receives immediately an email indicating that the students booked the time for that use, and if they don't complain, the supervisor is going to be charged. These are some statistics we had in this period. I learned a lot about the system yesterday when I had to prepare this. One thing is that I cannot separate per year this, and so there was no way I could see year by year. I already complained to the guy who put this together, but that was I got yesterday. We had 282 research projects in this period here. So FAPESP was 168, if I'm not wrong, CNPq 80, and so on. And we can see the research projects that contributed to the running cost or the cost of the lab. This, again, is the same chart that I showed before. And we can see that this is UFSCAR, this is USP, this is UNESP. Unicamp is a very, I think this green one, very small one. And these are companies, and the rest are spread in many, many different users. In fact, we had 1,018 users during this period, which means that 1,018 times that we issued a service order. They went there, they booked it, and we had issued a service order on this. And a very important point that I consider is that we have today, this is real present data, we have 419 users who are authorized to operate our equipment. And so the FEG, which I mentioned, we have 144, if I'm not wrong. The CM 120, we have more than 100 students and people from company. They can come and they can do their work there. And we can see that the newest equipment, we have less people as it's expect. This is our team. We are 3 people from the university, from the academic staff. I'm the coordinator of this. We have research associates from, at this moment, DEMa-UFSCAR. We have 3 technicians from UFSCAR, and that's a very important point. And we can hire from the money that we charge 2 technicians from our foundation, 5, and these 2 technicians, they are full-time hired for the lab. And we have 3 technicians which were, again, hired by the UFSCAR Foundation, but we also entered the CIS-Nano program, so now they are CNPq, they receive a grant from CNPq, and we have a trainee and administration, she's also paid by our money. We have an advisory committee. I had to think about this, and we have an advisory committee from many different projects. FINEP asked the advisory committee, so I have a list of names. FAPESP also asked I put all this together, but it's not completely formalized things. I just put this at lunchtime after Professor Bloom talked what they would expect for multi-users equipment. Institutional support, I think that we have from the building that we had and from the technicians that we have, that's very important, and other parts that comes from the graduate program. Publicity and visibility, I think that we are not too bad. We can do better, but we are not too bad. Operational costs were completely self-sustained. For operational costs, we cannot do investment. Funding for maintenance, we also are self-sustained. I put this together because that's a very important point for us. We don't do scientific collaboration. Many people ask, well, if I don't charge you, I can put your name. We don't do scientific collaboration. There is no possibility. Nobody in the lab, even the technicians, are allowed to do scientific collaboration. We can develop our projects, but we cannot appear in any papers from our users. And again, adequate place, I think that this is the main part of our lab. You can see here the two SEMs, and we have a small museum where we have this oldest equipment. And thinking about future investment in need, we are just acquiring a new TM, a 200 kV Lab 6. We are now expecting to be installed in August 2014. And of course, like many, many other labs, we are hoping to be able to have a focused ion beam for TM preparation, which is, I think, the main problem that we are facing now. So please, if you are interested, visit our homepage. Thank you very much for your attention.
Considering that you give the opportunity for students to use the equipment, how do you see the risk to have an increased cost and maintenance because of that? Yeah.
I answered this question since 1986. Yeah. And there is no increase in cost at all. At all. It works. Well, we had accidents, but with professors, postdoc, and undergraduate. And in fact, we have more accidents with postdoc than with the undergraduate. Of course, we don't have too many undergrads. Yeah? We don't have too many undergrads that operates. But when they want, it's free. It's really allowed to operate. In fact, we have right now we have 3 excellent undergrads who operate our 200 kV machine. That is, I think, is our top equipment. So that's it. But we have accidents. Huh?
I'd like to know how is the link of the laboratory with the university? Like, if they can ask for some changes or something. I mean, how is the management related to the university?
That's a very complicated question. Very complicated question. When we bought our Tech-9 200, we had to ask the university if we could be hanged on the Center for Science and Technology. But we are in the department. So FAPESP didn't ask that. So if you look at our even the Center of Technology, Science and Technology, if they need, they say that we belong directly to them. But most of the time, we are linked to the department. But the department, we are completely free to run the lab in a really open way. There is no facilities at all for people the facilities, of course, because they are there, but not for booking the time, for instance. Everybody has only 4 hours to book. There is no possibility to break this. And for me, even for me, so we have to book 4 hours for each equipment. After we use that hour, we can use that 4 hours, we can book again. So we have no extra facility for the department. So we run quite independently with one foot in the department and 1 foot in the center.
Good afternoon. Thank you, Brun and FAPESP for the opportunity to introduce you a program we are running at the medical school here at the University of São Paulo. Let me first introduce you our school indeed. I don't know how many of you know the medical school at the University of São Paulo is here in Pinheiros. It's not in the main campus of the university. And the medical school likes to define itself as an academic health center. We are at Clínicas station, subway station, together with the Hospital das Clínicas. So we are together part of the Secretary of Health, which supports the hospital and the medical school, together with a nursing school and public health school. So we are 3 units of the University of São Paulo within 3 blocks that have many different hospitals. The Heart Institute, the Cancer Institute, the General Hospital, the Psychiatry. If I'm not mistaken, we are 9 institutes and 3 schools. Some years ago, we started to organize the services that researchers would do for other researchers. So we decided to organize our multi-user facilities from the standpoint of a researcher that will serve another researcher with researchers. I hope we can change this after these workshops, and I'll tell you what are the direction of our changes. We do think that core facilities really represent the strategy for institutional support, the right way of spending the money, the institutional overhead that we have been receiving over the years. And as we are also part of the Secretary of Health, we also have support from the Secretary of Health to do research, and are not only treating with academic researchers, but also we are treating with people who are really working in hospitals, doing clinical research. So there is the opportunity there to do services that can be charged indeed. So one premise of this, the core facilities, would be to organize the services for research with the idea of having a share cost. So we try over the years to estimate the real cost of everything we are doing. So that doesn't mean that we charge for the service. Indeed, we are just starting to charge now, and it was great to know that other institutions are charging the researchers for a long, long time, as I heard here. So we tend to know what are the costs for all the services we provide. We also believe that core facilities are meeting points for collaborating groups. We understand that we are not collaborating, but as we provide the structure, we put people together, and I think this catalyzed interaction of different people, and interesting ideas can come through the interaction of people working in using the share facilities. It allows the rational application, the application of institutional resources. As I mentioned to you, we can hire people through the Secretary of Health to do research. We have the overhead, institutional overhead to apply, so we can have both financial resources and human resources to try to apply in a smart way to researchers. And obviously, as all of you heard today, we need specialized personnel to really take care of some of the equipment, and this is something I would like to discuss even further with those who are interested. Something which is critical for us is to have professional management, and we are all researchers. We are not professional managers. So we need to have a professional manager with us. I think this is critical. Even to really establish the real cost of the service and help us to calculate the price that we are going to charge, we do need professional manager. We do need special help. This is something, one of the bottlenecks we have to really fulfill the premises of multi-users that work. We need to have a strict way to evaluate the services. And this is not to evaluate the research we do, but to evaluate the services we perform and what we deliver. It's a little bit different. So we need to have ways to gauge performance, and we are working on that. All of this call for a cultural change. I think this is critical. I have no idea that the multi-users are a very virtuous idea. I don't know anyone in my institution who is against it. They all defend it. But the fact that they defend it doesn't mean that they really work for it. Very few people do work for multi-users, and this is something that we need to take into account. And as I mentioned to you, we need to calculate the costs and prices, and we need to agree upon the funding bodies to avoid that someone would have it to be easier to do a service in the neighbor because they have a collaboration, something like that. Then we'll do in our institution. So this is something that we need to come with a conclusion, in my opinion, and we need to come to FAPESP or to CNPq and now to CAPES and really decide what is fair to really charge for the service for a person who is within the university, within the program, and someone who is outside the university, outside the program. These are things I'd like to discuss with you later on. So, as I mentioned to you, we are squeezed among 8 hospitals and 3 units of the University of São Paulo. We don't have really space, or we may have some space, but we don't have that much space to build facilities. So we cannot concentrate everything in one place. So the strategy was to build a network and use informatics to connect all the laboratories who are serving the multi-user, the facilities. And this is the site we have. I invite you all to visit it and to use it. It's a premium for a program of Rede de Equipamentos Multiusuários da Medicina.fm-USP.br. So there you will find a list of all the equipments of all the laboratories that are some way supported by either by FAPESP, by our foundation, Fundação Faculdade de Medicina, FINEP, CNPq, or CAPES, that were somehow enrolled as a multi-user for a reason or another. Here you find many different laboratories in different moments of their implementation. For example, we will have a biobank for cancer specimens that is supported by the University of São Paulo, who still needs to be approved by the federal government to really act. Hopefully in the next month or so it will be acting, to be working, to be operational. We have a vivarium, a central vivarium who provides animals for research, and it's the oldest unit in the portfolio of multi-user equipments and facilities. And we have confocal microscopy, which is a very active equipment. All the others are in different phases of implementation. And you see the data when you visit the site. let me see if I can put this to run here. Let me see. Oh, I'm sorry. Is it working? No. I'm sorry. It was working over there. Anyway, please visit the site. You will see pages like this. As today, we have 2,200 users registered. We have over 320 visits to this site. And today, I've done many more, so to increase this number. The actual access was about 65,000 access, and we have different around 3,000 contacts through the website. We ask everyone to register, and we do make a difference if the person is from the academic health center, is from the main campus of the university, of is external, and we do charge. The idea is that we charge differently every one of these categories. We present the program here. Unfortunately, I cannot be more active with the site if it's not working. But anyway. And you have many pages discussing how the samples need to be prepared, for example, for the confocal analysis or for the cytometry or sequencing. There will be the contact of the coordination, what are the equipments, what is the material. We have many protocols that are listed here. Some laboratories include the production, some even the artistic production as the confocal. We have all the rules for utilizing the equipments, and in the way we are managing right now is to have an interview so we can have an actual understanding of what is the problem and how to tackle the problem using the multi-user, in this case the confocal. So there is an actual interview. We don't have unsupervised users. I'd like to learn with people from São Carlos how to really do unsupervised usage of some equipments. I'm a little bit skeptical of doing that, knowing the user from my unit. I'm very glad that people from São Carlos are different. But anyway, this is our reality. But even because people are not as professionally bound to research as people probably in other units. So we need to tackle different. I have a colleague here, for example, Eder has a ultracentrifuge, which is a multi-user, and he's very careful regarding who really uses and the way that the equipment is used. And then he's correct, and it's open, but he's careful. So it's a correct strategy, at least for us, right? The idea is that booking is still not open as a Google calendar or something like that. We do need to have the interview and then book through everything through the internet, but it's not an open. It's not open booking. And we've been doing this with very successfully with all the activities that are centralized in the vivarium at our medical school. We have different experiments that are booked at the vivarium, experimental research, and also projects of breeding animals and providing different animals for research. We don't have the costs in the site. We ask people to pass through an interview, and then we send a pro forma invoice of the service to the user. We don't have open prices, even because we do think that we need to come to the agency and really decide what people would consider correct to charge. This is something we need to go for. The newest kid in the block for this program is it's called PISA. Is under construction, and you see it. But anyway, is a program of imaging in the autopsy room. This is something that is for research is very, very unique in our academic health center, and this is something that will make a difference in terms of medical research. Few centers in the world indeed have the opportunity that unfortunately we have in São Paulo, a mega city where lots of people die violently and somehow needs autopsies. But anyway, this program will have is already working for tomography, and we'll be running for MRI, a 7 Tesla MRI that is to come hopefully at the end of next year. So the idea is that this center had already acquired a huge number of images of corpses, and maybe it should be very useful in the future for imaging, both human imaging and animal imaging. And right now, this is how it looks. The core facility. We are building the bunker for the magnetic resonance. It will be a functional magnetic resonance together with the autopsy room, and there will be a different entrance for animals that can be analyzed there. So please visit our website. I'm pretty sure that it will work much better in your computer than it's working here. Yeah. And give us your advice and complaints. Thank you.
Any questions? If not, I have a question, Professor Chammas. You have that's one of the reasons we wanted you to expose your Rede Premium. I wouldn't say unique, but a different way to organize the lab, because this was a strategic solution by lack of a facility. What do you suggest? Is this one way to do it, or is this to have a facility on its own is still the best solution, or it depends on the equipment?
Right, great. Thank you for asking, Bruno. I think this is the way that we should act with most of the equipments indeed. Obviously, there will be the case that I would like to have a center. All the sequences, for example, in the same room, having one person. But there are many things that I can do in my laboratory as a service. I have a technician from the university, hired from the university. I think if I organize that in this way, I can guarantee you that many equipments that I have are not booked all the time. So why not open for share the use? I think this is a way. Once we have it, we have a platform that we can really guarantee that the maintenance of the equipment is covered, and we guarantee that. As I mentioned to you, we are in the Secretary of Health together with the medical school. The Secretary of Health guaranteed the maintenance of the equipment. So we have the personnel, right? So why not open the agenda to everyone. So hopefully, I think that right now the paradigm from researchers to researchers with researchers will be changing from the institution to researchers with specialized personnel, assistant researchers that are not PhD students, they are not postdocs, but they are hired specifically to run the facility. So this is the way I think. And I think a network would work. Obviously, we need to have a center, but a facility, a program like this would work.
Roger, I didn't really understand. You said that one moment that you don't charge for the use, and the other moment you said that you have different prices for different users.
Right.
So the question is more general than that.
Yeah.
You have full subside for that?
Yes.
Or
right
do
now
you
is
think that you should go for autonomy?
So we think we should go towards autonomy, to sustainability, yes. We know the cost, and we inform the cost to the researcher. We don't charge the researcher. Okay, so for example, for the confocal unit, we know that we had services. If it had been charged, we would have like 56,000 reais last year. And I send this as an account to the director, okay? So the director knows everyone who uses our facilities. The research committee knows everyone who uses the facility and what would be the cost and what was the investment of the institution in the researchers. So we know the cost. What we don't do is transform the cost in price, so we don't have the money from the researcher, but the institution paid anyway. There is no free lunch, right? So it costs to unless we come for a FAPESP, then we have a free lunch. But otherwise, we don't have free. There's no free lunch, right? So the institution knows exactly what is the cost, and the researcher now knows the cost. And we are now asking the researcher to have that planned in their projects so he can bring in the money. And they are doing that. For animals, we are doing that. And now we are getting the money and investing more and more in the vivarium, besides the institutional overhead. But we have the numbers. So if I sit every month with the director and say we are donating that amount of money to our researchers, and we keep doing that so far.
Well, we've come to a closing session. I mean, final remarks. I'd like to thank, first of all the speakers from today. They were very enlightening presentations, and I hope everybody enjoyed as much as I did. I'd like to thank you all the participants, particularly those who stayed here till the end, but all of them. I think I will be very brief. I don't want to take much of your time. And just to mention some points, some aspects that called my attention, and actually that were our concerns since the very beginning of this, when we started discussing about organizing this first workshop on multi-user equipment in facilities. I mean, the first thing is that I think we are at FAPESP, but not only at FAPESP, I mean, I'm sure all the institutions, we were very happy to see that although facilities and multi-user institutions already exist and have been around for a long time, I think there was quite an intensification of that. I mean, there are more of these facilities. The community, our community is understanding that this is probably the best way, I mean, we can do to have the top-level equipment. And I mean, we saw some of facilities that have been recently created and they are being developed. And I think this was something, a great satisfaction for all of us. And I'm pretty sure this is the direction we should continue to move. We try to make clear, make clear not, but with the range of presentations, one thing we wanted to emphasize is that there is not a unique solution. I mean, there are national laboratories, and I will take the opportunity to emphasize my concept of national laboratory. National laboratory for me is almost always, if not always, organized around a big instrumentation, a unique instrumentation that cannot be done anywhere else. And then eventually you build some other facilities around it to take advantage of that equipment. So this is a national laboratory, and it operates in a completely different way than a facility. But then you have facilities, because you have middle-size equipments which are becoming more and more complex. Mid-size, I mean, $1 million, $5 million is not mid-size, but it all depends on where you range. If you look at a synchrotron near $500 million, then you probably call this mid-size. But facility is clearly, I would say, something that has to progress the concept in our community, and we have to continue to develop them. And I think this will be the way we will be able to continue to have the best equipment in this state and the country as a whole. But then there are other equipments that are not as large, and or eventually they are more dedicated for some experiments, and that's the experience from the Rede Premium that Roger Chammas just presented to us. I think this is something that we should with much care, take care of this experience. I think this is a very good solution, because many multi-user equipments are located in research laboratories, and I'm pretty sure, I know that, it's not easy to operate as a multi-user when you have a research laboratory. Actually, you don't want to do that. But if you organize this in a network, and then you can make this much easier and much more efficient, and probably this is something we should consider also for the user. And I think, more and more we are going to ask, and we have that already, and the universities responded to the call from FAPESP. Facilities were built. This was great. But more and more, the participation of the institutions, universities, research centers will be necessary in this effort. And I think the last comment I would like to mention, that it's probably the next step we are going to focus more and more, is that now we have to go after our users and change their culture. And they have to understand that they can do very nice research using the facilities. And that's actually much easier, a much better way to do it. You can top-level equipment, you have technical assistance, professional assistance, which is very important. And instead of spending half of your time, if no more than that, trying to operate a large equipment, and most of the cases, the equipment is sitting idle because there is no use for it, which is really something we cannot afford it. So I think this is the facility, the people who are operating facilities and multi-user equipment, I'm sure will help all of us to go and try to change little by little the culture of our research community. So with that, once more, I want to thank you all, and thank you very much for coming. Bye.